Welcome to Lecture 5 on matrices. In this lecture, we shall be dealing with the minor, cofactor, and adjoint of a matrix. I remain your lecturer, Professor E.O. Efanga. The minor. Given an n by n square matrix A with entries Aij, if we delete row I and column j of this matrix, then the matrix reduces to an n minus 1 by n minus 1 square matrix. The determinant, denoted by Mij, of this submatrix is what we call the minor of A associated with the element Aij. The cofactor. The value given by Cij equal to minus 1 raised to power I plus j times the minor Mij is what we call the cofactor of A associated with the element Aij. We observe that in this formula, if I plus j is even, then Cij will be equal to Mij, since minus 1 raised to power even number is plus 1. Also, if I plus j is odd, then Cij will be equal to minus Mij, since minus 1 raised to power odd number is minus 1. Thus, the cofactor is often regarded as a sign minor. Example 1. Let us consider this 3 by 3 square matrix A. If we delete row 1 and column 1, then the minor of A associated with A11, A11 in this case is 2, is M11, which is equal to the determinant of this submatrix 3, 1, 3, 5. And that determinant will give us 15 minus 3, which is equal to 12. And the cofactor of A associated with A11 is C11. And C11 is equal to M11, since 1 plus 1 is even. So therefore the cofactor is also equal to 12. Now let us delete row 1 and column 2. Then the minor of A associated with A12. A12 in this case is this element 1. The minor is M12, which is equal to the determinant of the submatrix minus 4, 1, 2, 5. And that determinant will give us minus 22. And the cofactor of A associated with A12 is C12. And C12 is equal to minus M12, since 1 plus 2 is odd. And that will give us 22. Next, we delete row 1 and column 3. Then the minor of A associated with A13, A13 in this case is this element 2, is M13, which is the determinant of the submatrix minus 4, 3, 2, 3. And that determinant will give us minus 18. And the cofactor of A associated with A13 is C13. And C13 is equal to M13, since 1 plus 3 is even. And that will give us minus 18. Now, let us delete row 2 and column 1. This is row 2 and this is column 1. Then the minor of A associated with A21. A21 in this case is -4, is M21, which is the determinant of this submatrix 1, 2, 3, 5. And that determinant will give us -1. And the cofactor of A associated with A21 is C21. And C21 will be equal to -M21, since 2 plus 1 is odd. And that will give us 1. Next, we delete row 2 and column 2. This is row 2 and this is column 2. Then the minor of A associated with A22, A22 is this element 3, is M22, which is equal to the determinant of the submatrix 2, 2, 2, 5. And that determinant will give us 6. And the cofactor of A associated with A22 is C22. And C22 is equal to M22, since 2 plus 2 is even. And that will give us 6. Next, we delete row 2 and column 3. That is, this is row 2 and this is column 3. Then the minor of A associated with A through 3, A through 3 in this case is this one, is M through 3, which is the determinant of this submatrix 2, 1, 2, 3. And that determinant will give us 4. And the cofactor of A associated with A through 3 is C23. And C23 is equal to -M23, since 2 plus 3 is odd. And -M23 is equal to -4. Now let us delete row 3 and column 1. That is, this is row 3 and this is column 1. Then the minor of A associated with A31. A31 in this case is this element 2, is M31, which is equal to the determinant of the submatrix 1, 2, 3, 1. And this determinant will give us -5. And the cofactor of A associated with A31 is C31. And C31 is equal to M31, since 3 plus 1 is even. And that will give us -5. Next, we delete row 3 and column 2. This is row 3 and this is column 2. Then the minor of A associated with A32 is M32. And M32 is the determinant of this submatrix 2, 2, -4, 1. And that determinant will give us 10. And the cofactor of A associated with A32 is C32. And C32 is equal to -M32, since 3 plus 2 is odd. And that will give us -10. Finally, we delete row 3 and column 3. This is row 3 and this is column 3. Then the minor of A associated with A33, A33 in this case is 5. So that minor is M33, which is equal to the determinant of the submatrix 2, 1, -4, 3. And this determinant will give us 10. And the cofactor of A associated with A33 is C33, which is equal to M33, since 3 plus 3 is even. And that will give us 10. We have computed the cofactors of all the 9 elements in this matrix. The adjoint of a matrix. The adjoint of a matrix A is the transpose of the matrix of cofactors associated with every element of the matrix A. The adjoint of a matrix A is abbreviated as this: ADJ in bracket A. Let C be the matrix of cofactors of A. Then the adjoint of A is equal to C transpose. Example 2. Again, let us consider this 3 by 3 square matrix A. Then the matrix of cofactors of A is this. We have already computed all the cofactors of this matrix in example 1. So the matrix of the cofactors C is C11, C12, C13, C21, C22, C23, C31, C32, and C33. And this is the matrix of the cofactors. So therefore, the adjoint of A is C transpose. Transposing this matrix will give us this, which is the adjoint of the matrix A. Now let us see how we can compute determinant using cofactors. The rule is to choose any row or any column. Then multiply every element in that row or column by the associated cofactor, and then sum to get the determinant. That is, for an n-square matrix A, if you choose to evaluate the determinant using row I, the determinant A is equal to sum of all the elements in row I multiplying by the cofactor associated with them, and then sum. That is sum of Aij, Cij, as j goes from 1 to n for any row I. But if we choose to evaluate the determinant using column j, the determinant of A is obtained by multiplying every element in that column by the associated cofactor and then sum. That is sum of Aij times Cij as I goes from 1 to n for any column j. Example 3. Let us evaluate the determinant of this 3 by 3 square matrix A. Let us use row 1 to evaluate this determinant. Using row 1, the determinant of A is A11 times C11 plus A12 times C12 plus A13 times C13. That is 2 times 12. C11 we computed it to be 12 plus 1 times 22. That C12 is 22 plus 2 times minus 18. C13 is minus 18. When we multiply and sum, this will give us 10. Or let us use column 1 to also evaluate the determinant to see whether we will obtain the same answer as using row 1. Using column 1, the determinant is A11 times C11 plus A21 times C21 plus A31 times C31. That is 2 times 12 plus minus 4 times 1 plus 2 times minus 5. Again, if you multiply and add, this will give us 10, which is the same as the result obtained by using row 1. If you choose to use column 2, you still arrive at the same answer by multiplying 1 by its cofactor, multiplying 3 by its cofactor, and 3 by its cofactor, and then sum. Similarly, if you use column 3, you still arrive at the same answer. If you use row 2, the answer will be the same, and if you use row 3, the answer will be the same. We have come to the end of this lecture. Thank you for watching, and keep on watching.